Welcome to our Pollution Group project video. This video will do about the pollution case to raise awareness about the severe water pollution issues in Malaysia and highlight the importance of protecting raw water sources for public health and environmental sustainability. What is water treatment in Malaysia? Water treatment process in Malaysia is a sophisticated, multi-stage operation designed to transform raw water, primarily sourced from our rivers, into clean, safe drinking water for the population. But now, this vital system is currently facing a crisis due to increasing pollution and contamination. Issues such as industrial discharges, agricultural runoff, oil spills, and improper waste disposal are reaching critical levels, directly endangering public health and our national water security. To provide a concise overview of this case study, in November 2025, a severe turbidity pollution incident was recorded at Sungai Johor in Kota Tinggi. The primary contaminant was extreme levels of turbidity, which spiked to a staggering 37,400 NTU. As shown in the image, the water quality was heavily compromised by sediment and debris, highlighting a critical threat to our local raw water sources.
So, what exactly caused the contamination of Sungai Johor? From Datuk Seri Johari Abdul Ghani, the Plantation and Commodities Minister, he said that
the pollution originated from a breach at Silt Pond No. 6 in a sand mining area, causing muddy water to flow by gravity into nearby water channels, which is Sungai Johor.
They found that the contaminant involved sediment, silt, and suspended solid. But it still remains unclear that whether the contaminant contains purely clean soil, which are silica, sand or clay, or contaminated soil or dredged materials that contain heavy metals, hydrocarbons, or other
Next, the impact/consequences of the problems. First, water treatment plants were shut down because turbidity levels were too high to process. This affected the Sungai Johor, Lingjiu, and Semanggar water treatment plants. Next, large-scale water cuts occurred, affecting around 800,000 users. Areas impacted included Kota Tinggi, Johor Bahru, Kalai, and Pontian. Finally, the pollution caused economic losses. Fishermen lost their income, and water-dependent small businesses were unable to operate. The lack of clean water can create a public health emergency. Communities may face disease outbreaks, and hospitals could become overloaded as more people get sick.
What should we do when turbidity reaches 37,400 NTU? Therefore, these are some of the emergency countermeasures for high turbidity events. We will explore 3 essential techniques designed to reduce suspended solids and prevent water treatment plant shutdowns. So, firstly, pre-sedimentation tanks or lamella clarifiers. The objective is to reduce excessive suspended solids and prevent process overload. Secondly, by deploying mobile coagulation flocculation units. By rapidly adjusting coagulant dosage during extreme turbidity, these units shorten flood settling time and stabilize treatment performance. Thirdly, the deployment of sealed curtains and sediment barriers upstream. By physically containing suspended solids near pollution sources, sediment inflow into water intake zones is significantly reduced. These barriers act as a first line of defense, limiting the downstream transport of fine particles during high flow events. As a result, raw water quality treatment plant is taken now. Let's imagine a sand-sealed pond with a very weak structural integrity, gradually deteriorating under fast-flowing water. Over time, the structure fails, releasing large volumes of suspended solids into the river. Therefore, let us explore how geotextile reinforced embankments can improve sand-sealed pond performance. Turbidity in sand-sealed ponds often results from embankment slope failures. These failures release sediment suddenly, causing severe water cloudiness. By installing woven or non-woven geotextiles within pond embankments, slope stability can be significantly enhanced. Geotextiles increase the shear strength of pond walls, reducing the risk of structural failure. This structural stabilization prevents sudden sediment release, greatly reducing turbidity within the pond water. Here, we can see how geotextiles are installed within the embankment layers, reinforcing the soil structure and ensuring long-term pond stability under high flow conditions. Next, we move on to innovations in water treatment plant design. Water treatment plants are rapidly evolving, incorporating smarter technologies to handle significantly higher turbidity loads. The first innovation is AI-enabled turbidity monitoring, such as TinyML sensors. TinyML sensors enable early detection of abnormal turbidity, optimizing chemical dosing, and reducing response time by up to 60%. The second innovation is extended hydraulic retention time. Auxiliary basins increase hydraulic retention time, allowing more solids to settle and preventing treatment plant shutdowns. Lastly, a high-capacity filtration systems compared to conventional sand filtration. A dual media and membrane-assisted filters manage 2 to 3 times higher solids loading, with up to 10,000 hollow fibers, each 100 of times thinner than human hair. This technology maintains high filtration efficiency, ensuring clean water even during extreme turbidity events.
So here, we're looking at the preventive measures that can help reduce the risks caused by sand mining. First, there should be an immediate suspension of operations, along with a full audit of all sand mining sites. This is important because stopping work right away helps prevent further damage and gives authorities time to identify problems and fix them before operations continue. Next, we need mandatory upgrades to silt ponds and drainage systems. By strengthening these structures, we can prevent overflows, breaches, and uncontrolled sediment runoff that often pollute nearby rivers and waterways. You can help protect Sungai Johor, reduce waste, prevent pollution, support clean water initiatives. Together, we protect our river and our future.